Students, today we will learn operation on surd. Operation means addition, subtraction, multiplication and division. The rule for addition and subtraction is, suppose if these two surds are like or similar surd, then if the surds are like surds, then only addition and subtraction of that given surd is possible. So here I write this similar surd as a common, and then here I add these coefficients p and q. Therefore, to do addition and subtraction we compulsory required like surd. If the surds are like surd, then only we can add, otherwise subtract. So let us learn first this example. See, it is already like surd with different coefficients. Here the surd is root 3. So you can take this root 3 as a common outside this bracket and then write down coefficient of first surd, that is 7, here plus 2, and at last minus 1. So now do this first addition. So when you add, you will get 9 minus 1, bracket complete, root 3, and its subtraction is now root 8 root 3. So here I write it. In question number 2, you can see these surds are different, but these surds are similar surds. So first convert this or simplify it. So here I am simplifying this root 20. So you can use here one square number, that is 4 into 5. So when this 4 comes out, it will become 2 root 5. So this is the simplest form of this root 20. Similarly, root 45 can be write in the form of 9 5s 45. So again, when this 9 comes out, this surd sign, radical sign, then it will become 3 root 5. So this is the simplest form. Now substitute these values in this given question. So here I am substituting 9 root 5 remain as it is, minus root 20 is nothing but 2 root 5 plus root 45 is equal to 3 root 5. So next step, we have to take this surd outside and we will write the remaining terms in this bracket. So first subtract it. So its subtraction is 7 plus 3 is equal to 10, and it's root 5. So 10 root 5 is the final answer. Because we cannot simplify further, let us see next multiplication. Rule for multiplication. If suppose these are the two surds, it may be like surds or unlike surd. So here I write, if p nth root of a and q nth root of b are any two surds, then its multiplication can be written in this form. Here I multiply coefficients. If coefficients are given, then multiply that coefficient, and we can take this radical symbol common and we can multiply these radicands. This multiplication is possible only when their orders are same. Then only we can use this rule. So let us simplify or multiply this first number. So root 15 and root 6, these are two different surds, or you can say unlike surds. So here I am directly using this radical sign as a common symbol. Then here I am writing first radicand 15 into second radicand 6. So before multiplying, try to factorize it. So you can factorize 15 as 5 3s are 15, and 6 factors of 6 are 3 into 2. Okay, so here now take pair of two same number. So you can pair here 3. So we can write this 3 as 3 square into 5 into 2. So when this 3 square come out this radical sign, it will become only 3 because square and square root will eliminate each other. So therefore here I get these steps. So here I take this root 3 outside this bracket and here I multiply these two numbers. So we will get this final answer 3 root 10. Let us solve next one. Here this next question is with some coefficient. So use this rule. Here the value of p is 4 and the value of q is 3. So here I am first multiplying only coefficients. Then write down first radicand 21 and second radicand 39. So here you can do multiplication. 4 3s are 12 and in bracket here do not do its multiplication. First factorize it. So 7 3s are 21 and this 39 can be factorized as 13 3s are. Okay, so again you can take these 3 and 3 in a pair. So here I write some steps. So here I take this 3 square. Now take this 3 outside this radical symbol. So it become only 3. And in this radical sign 7 into 13 is equal to 91. So this is the multiplication of this given question. Now let us see rule for division. Here again these are two any surds. It may be like or unlike. Then its division can be written in numerator and denominator form. Okay, so here again the compulsion is their order of surds has to be same. So here you can see in both surds the orders are n and n. So therefore we can take this radical symbol as a common and we can divide this radicand. So let us study first example. Here this example we can write root 32 divided by root 4. So here I am using this radical sign as a common symbol and here I am dividing 32 divided by 4. So its division is 4 ones are 4 and here 4 8s are 32. So here our answer is root 8. So again we can factorize this root 8 because it is in the form of 4 into 2. So we can factorize it 4 2s are. Okay. So here I write all these steps. So when this 4 comes out from this radical symbol, it will become 2. So 2 root 2 is the division of this given question. Let us study the next one. Here also we can write these two surds like this. So 14 divided by 2 is equal to 7. And here we can take this radical symbol common. So 75 divided by 5. So we will get here its answer root 15. Now if you factorize it, you will get 5 into 3. Okay. So 5 and 3 both are not square number. So you can keep it as it is 7 root 15. So this is the final answer of this division. Now let us study rationalization of surd. Here the word is rationalization, means we will convert the given irrational number into rational number. Okay, so here you can see root 5. So root 5 is an irrational number and we will convert it into rational number. So therefore this process is called rationalization of surd. So here one sentence is written: if the product of two surds is a rational number, then each surd is the rationalizing factor of each other. It means here if we have to rationalize this root 5, then we have to select 1/3 such that we will get rational number. So here suppose if you simply use root 5, so you know root 5 into root 5 is equal to root 5 square. So you can eliminate this square and square root symbol. So you will get its answer only 5. So this 5 is nothing but a rational number. Okay, so this given question, otherwise here we select one new root 5. So both are rationalizing factor of each other. Similarly, we can take suppose if I take here 3 root 5. So when you multiply, you will get 3 into again root 5 bracket square. So which is equal to 3 into 5, which is equal to 15. Okay, so 15 is again here we are getting rational number. So you can say this number is also rationalizing factor of this given question. Similarly, you can use suppose 5 into, suppose here I use 80. Okay, so you can multiply these both numbers 5 into 80. So when you factorize this 80, you can use here 5 16s are 16 5s are 80. So you can pair it, and 16 is already square of 4. So when these both numbers come out, it will become 5 and 4, which is equal to, we will get 20. So here we are getting rational number. So this root 80 is also rationalizing factor of this root 5. So here I write some rationalizing factor of root 5. Here I used root 20, root 45 and root 125. So when you multiply it and when you factorize it, you will finally get these rational numbers. So from this we can conclude that this root 5, root 20, root 45, root 125, similarly we solve for root 80, 3 root 5. These are the rationalizing factor of root 5. So from these examples we can conclude this rationalizing factor of given set is not unique. See, it is not unique. These are so many. So from this rationalizing factor we can select any one and we can factorize this given irrational number. We can rationalize this given irrational number into rational number. So let us solve some example. Here the question is root 12. So you can simply use the same number, root 12. So root 12 is a rationalizing factor of root 12. So when you simplify it, you will get 12, which is a rational number. Okay. Otherwise, you can factorize this 12. See, if the factor of this given radicand is in the form of square number, then only factorize it. Okay, otherwise directly use this given rational number for as a rationalizing factor. So this 12 we can factorize in the form of 4 because 4 is a square number. So here I am using 4 3s are. Okay, so when you take this 4 outside, it will become 2 root 3. So root 3 is a irrational number. Okay, so we can multiply or we can select root 3 as a rationalizing factor to rationalize it. So when you multiply it by root 3, it will become, its answer become 2 into this root 3 square, which is equal to 3, and we will get 6. So 6 is a rational number. So here I solve it. Here I just simplify and root 3 is the simplest irrational number from this given set. So here I select this root 3 as a rationalizing factor to rationalize it, and finally we get 6 as a rational number. So let us study rationalizing denominator. Now you know how to rationalize, and now we will rationalize only denominator. If the surd is at denominator, if its q is in the form of root 9, so here the denominator is root 5. So when you are rationalizing the denominator, concentrate on denominator only. Do not look at numerator. So here the denominator is root 5. So root 5 can be rationalized by using rationalizing factor root 5. Otherwise you can select other rationalizing factors also. You know there are too many rationalizing factor. So select the simplest one, which is the easiest one. So here I am selecting root 5. So first multiply and divide also, so that when you multiply and divide this rationalizing factor to the given number, so it will eliminate each other and the value will remain as it is. Okay, so therefore we are dividing and multiplying. So here I write this step. So do this multiplication, numerator to numerator, it will become 4 root 5, and when you multiply denominator to denominator, it will become bracket square. So again square and square root get cancelled, and here we finally get 5, which is a rational number. So this process is called rationalizing denominator. Let us see the next one. It is the simplest one. Here we will select rationalizing factor root 3. Otherwise you can use this other rationalizing factor also, because we can convert these 12 as 4 3s are. Okay, so 4 is a square number. Here also 75 you can convert 25 3s are. So here I am just creating it by using any square number. Here you can take any square number into 3. Suppose you can take here 36, square of 6. So when you multiply, you will get 108, root 108. So you can select this factor also to rationalize the denominator. So I think you know how to rationalize it. You can select here one more factor. Here I am showing you how to create this rationalizing factor. Here we have to remove this root 3. So therefore here I am using 3 compulsory, and then write down here any square number. So suppose here I am writing 49. So 49 is a square of 7. So when you multiply it, it will become 147. So you can use this 147 as a rationalizing factor. So out of this you can use any one. So here I am just simplifying using the simplest method. Here I am using root 3 as a rationalizing factor. So here I am multiplying and dividing also. So when you multiply and divide at numerator and denominator, you will get this step, and finally this denominator become only 3, which is a rational number. Let us solve the next one. Here also you can select directly 72, root 72 as a rationalizing factor. So when you multiply and divide it by this rationalizing factor, you will directly get this 72. Otherwise you can use one more method, or one more rationalizing factor. Just observe this 72 and try to find out its factor. Is it factorized in the form of square number? Yes, you can use here 36 2s are 72. Okay, so here I am just simplifying this 72. So 72 can be written in the form of this square number as 36 2s are, which is equal to 6 root 2. Okay, so first simplify it. For further simplification, to convert this irrational number into rational number, we have to write its rationalizing factor, or we have to select this root 2 to rationalize it. So here I am selecting this root 2, and here I just multiply and divide. So when you multiply with 5, it will become 5 root 5. This numerator remain as it is, but see at denominator root 72 into 2. So here I factorize it. So 36 into 2. So 36 is a square of 6. So when you take it outside this radical sign, it will become 6, and it's 2 into 2 becomes 4. So when it comes out, it will become 2. So 6 into 2, which is equal to 12. So 12 is a rationalizing factor. Here also you are getting 72. 72 is also a rational number, and 12 is also rational number. Let us solve one more question. 3 upon 4 root 7. So you can use here 4 root 7 as a rationalizing factor. Otherwise you can directly use only 7 because it is the simplest form. 4 is already rational number. The irrational number is root 7. So we have to only rationalize this root 7. So you can concentrate on this root 7 only. So this root 7 can be rationalized by multiplying root 7. You can use other numbers also. Like I use here 4 into 7, which is equal to root 28. Okay, so you can use root 28 also, because when you multiply and solve it, you will get finally rational number. Here also you can use 63. 9 7s are 63. So root 63 is also rationalizing factor of root 7. But try to select the simplest one. So when you multiply and divide by root 7, this denominator becomes rational number. Here I am just multiplying this numerator, so you will get this step. And when you multiply at denominator, this root 7 into root 7 becomes bracket square, so which is equal to 3 root 7 divided by 4 into 7. Okay, so finally we will get this denominator 28, which is a rational number. So that's it in this video. See you in the next video with binomial surd like this. These are the binomial surds because here the terms are 2. So therefore it is called binomial surd. We will find out its conjugate and we will rationalize the denominator which will be in the form of binomial surd.